Hello everybody, it's great to have the opportunity to talk here at the RoboCon 2023 online edition. This talk is called Ninja Robots. It's about methods of solo partitioning robot framework. Let's first have a look at the agenda. There will be an introduction of myself. Who am I? How did I gain the experiences I'm going to share with you today? I will tell you what I believe is, or what my experience is, the difference between solo and team effort with respect to robot framework. And then we will make a run through the tool set I used as a solo practitioner, which is going to be Git, a version control system, which I will show how to use both dynamically as well as statically. Raiden, a tool that helps to measure the complexity of source code and substitutes for reviews. And then we'll have a look at advanced unit testing methods, hypothesis, which helps you find and know the limitations of your implementation, and CosmicRay, which helps you to find gaps in your unit test suite. And then we will have a look where all this leads to. So orthogonality, you can change one piece of your system without affecting the other pieces of your system, which is really great. Low complexity, micro commits, and high test coverage, which is in total the world I like to be in. So first, let's have a look at the introduction. Who is talking? I'm an electronics engineer. I worked both before I went to university as well as after I went to university. I'm working for a silicon manufacturer right now, where I have been an application engineer, I have been a pre-silicon verification engineer, post-silicon validation engineer, and production test development. I'm doing now also a little bit the last two things I'm doing right now, and all these four things I did to some extent using robot framework. Next, let's have a look at the differences between working alone and working in a team. In my experience, these are the most important points to look at by comparing these two situations, and they are more similar than you probably expect. Compromises, you need to do them when you're in a team because you have teammates. When you're alone, you're very restricted in resources and influence and all these things, so you need to do a lot of compromises as well. Reviews are awesome when you're in a team. When you're alone, you need to substitute for them. This is going to be part of this talk. Motivation works very differently whether you're in a team or not. This is not going to be part of this talk. And communication is very different. When you're in a team, it opens new perspectives. It helps you to grow and understand and all these nice things. When you're alone, you can only listen to your former self, which only talks and never listens. And you can only talk to your future self, which only listens and never says anything useful. This is very different, and this is going to be part of this talk, the part about version control Git. And then there's examples and documentation. For me, there's not a big difference whether you're in a team where you need that to communicate with your teammates, or when you're alone where you need that to defend your findings. I work in quality control, quality assurance, so my results are going to get challenged, whether I want it or not. And at this point, I need to provide examples, documentation. Otherwise, my results will not survive the challenge. So first thing, communication with yourself, with your future self or your past self. Git log --all -s, the string you're currently interested in. This allows you to look at all the commit messages, all the commits that have introduced or removed a certain string in the past. And this is a way to communicate with yourself, where you can then look at what was my mindset back then, what have my feelings been, what time of day was it when I was working with this thing. And that helps to come back with memories. It helps to keep your feet grounded and connected to reality instead of meandering away in some pseudo-reality, and helps you to efficiently communicate with yourself from the past. Let's have a look at an example from the robot framework codebase. This is the JS result writer. It's a class name. And this is the list of all the commits that have introduced or removed this string. And you can see it was a very bracketed time where this string was introduced or removed actively between early December and early February. All the commits to this topic were done by either Packer or from a group account, which was influenced by Packer a lot. And you can see that there are long commit messages with the explanation what's going on and stuff like this. And there are very concise commit messages. And when you look at this, you kind of get a feel what is going on with this class. And when you look with this method on the code that you're actually testing, you can also learn a lot about what you're testing, where to look at, and focus your efforts on juicy targets. There's another way to communicate with yourself through time using Git, which is Git bisect. This allows you to say, okay, this is a testable property and have a test to check whether this property exists or not. I know it exists in that commit. I know it does not exist in this commit. Git, please tell me which commit actually changed the property from existing to non-existing, or the other way around. And this helps to compare your expectations with reality. And again, puts your feet on the ground, keeps me connected to reality, allows me to not meander away in some pseudo-reality, but know what's going on and be data-driven and have facts in my hand. This is really, really helpful. This was the part about communication with your former self and your future self. Next is going to be review without review data, so substituting a review data with Raiden. Raiden is a tool that objectively measures the complexity of code. I personally like the McCabe index. The McCabe index is roughly the number of unit tests you need to achieve full test coverage. So if your module has a constant, it's +0, you don't need to test constants, they are just what they are. Functions, methods, they are +1 because you need the unit test for those. If, while, for, except, all these things, add 1 unit test, so it's +1. Okay, what does this value mean? This value is a really good predictor for how hard is it to understand some code and how hard is it to test some code. And it's also really good at detecting areas of technical debt and keeping the technical debt on your radar, knowing where have you accumulated it, how much is it, and is it going to affect my next steps? Because if you have this orthogonal system, that means you can say, okay, I have a lot of technical debt in this component that I'm not using, and it doesn't look like I'm going to use it in the near future, so maybe we can just leave it there. So this is really, really valuable that you get knowledge of where your technical debt is, and then you can make an educated decision on what to do about it.
This is the example about the usage of Radon to get the cyclomatic complexity out of some code. I'm using the robot framework code base itself as an example, and because this is relatively large, I'm going to just use one file, but you can use that on the entire project. As we have recently discussed, if you follow these recommendations, you will not end up with a large code base, so this problem does not apply to you. If you run this command, we have selected the cyclomatic complexity and we have provided the -s flag, which asks for giving the number as well instead of just the letter. We get this type of output. So we see what the thing is that we are looking at. It can be a function, a class, or a method, and how complex it is in a rough given value. That's the A, B, C, D, and the CC number itself, 7 in case for the safe string. So let's have a look on how these values correspond to how code looks that has this type of complexity and how this value gets constructed. So this is the function safe string, and as you can see, it's a function, so it's +1. There's an if statement, 2, 3, 4, 5, 6, 7. This is how the 7 comes out of the cyclomatic complexity. And if you would want to do some refactoring to make the code meaner and leaner, you would actually have a good choice to start here, because this is already very compact. There's not much to do anymore. Same thing here, that's relatively compact, and it goes on. So this is a good indicator of where to start if you are in the process of taking care of accumulated technical debt.
Next, what we are going to look at is unit testing. And when you are alone, you don't have a human review partner or colleague that helps you to know where you are and what's going on and reviews and checks you, challenges you. You can do reasonably well using the tools Hypothesis and CosmicRay. They can control the quality of a unit tests reasonably well. The two things that humans can do, which those tools do not do, which are of very high importance, humans can act as a deputy and replace you when you go on vacation or something. And also humans have an opinion on what is a good or a bad name for something. But apart of that, these tools can cover you reasonably well. Hypothesis helps you to find the limitations of your implementation, and CosmicRay helps you to understand how tight your unit tests are. Let's first have a look at Hypothesis. The way Hypothesis works is that you write a normal unit test that's parameterizable, and you tell Hypothesis which type of parameters are acceptable for this unit test. And then Hypothesis tries to find some parameters that fail the test. And this allows you to find the limitations of your unit test. So if you use floating points, for example, and the values get too large or too small, or the ratio between them gets too small, or at some point the numerics will not work anymore and your accuracy will not be acceptable anymore. And Hypothesis allows to structurally document and find these limitations, and these unknown limitations then become tested and known limitations, which is a big step in the right direction. There is an example of this in this talk.
This is the Hypothesis example. What you can see here is a regular test case. It is written in pytest and uses Hypothesis. So you have here parameterized unit test, and it uses the fact that these two operations are reversible. So if you convert the drop time, you calculate the drop time from the height, you can then reverse it by calculating the height from the drop time, and there should be the same result out of it. And also all time durations need to be positive. This is the test case, and this is our implementation. And yes, this implementation is correct, but it does have limitation. And we can use Hypothesis to find this limitation. So here we can see that when Hypothesis chooses a really large number, then the results are not anywhere close to the correct result anymore. So how can we fix this? We can give a max number for that. And let's see if that now fixes the situation. It still does not fix the situation. We still have a problem with negative values, so we have to provide a min value. Now we have documented all sensible limits to this implementation.
The next thing we are going to look at is CosmicRay. The CosmicRay does something different. CosmicRay doesn't check the limitations of your implementation, it checks the limitations of your unit tests. The way it does it is it takes the source code that you try to test and changes it in a way that is most likely a bug. It takes a plus and makes a minus there or something like this. And then it runs the unit tests. And this changed code, this mutated code, if that one fails the unit test, it's a killed, it's a dead mutant. But if it passes the unit test, that means that can mean a couple of things. One of the things it can mean is that this code is just not tested. There's test coverage missing. Another thing that it can mean is that this is dead code. No matter what you do, this code will never execute. It also could be the case is that this is irrelevant code. So this gets executed, but no matter what comes out of this code, it will be overwritten a few lines later. And all of these things can help you to, all these inputs you can act on, and they help you to get better unit tests and better code quality in total. Let's have a look at an example of this. This is an example that I made back then. I didn't do this on purpose. This is a mistake I do surprisingly often. These are two functions that are physics simulation with floating points. It calculates the height of a drop from the drop time or the drop time from the height of a drop. And in the unit test, I chose the value 5. And 5 is an integer, and therefore it's possible that if the last operation on this unit test changes from a floating point operation to an integer operation, the unit test cannot detect it. So this is a limitation of the unit test. The solution is easy. You just need to replace the 5 with some non-integer floating point number. And this mutant would not survive anymore. One of the things that this pushes to is there is an absurd large amount of bugs possible. So if you have a large code base and you run CosmicRay on it, it takes a very long time. But if you have small independent code bases, it goes reasonably fast. So it pushes you in the direction of having orthogonal units, which is great. So if you do all this, where does this lead to? Well, as we just said, CosmicRay pushes you to separate your code into small pieces that are individually sufficient to exist and independent of each other, correct or incorrect, so orthogonal pieces. It also pushes you to have good test coverage by removing dead code, removing irrelevant code, and if you forget a unit test, it will tell you and you can react on it. Raiden pushes to have simple code and known technical depth and just have an eye on where the corpses are buried, which helps you to not clean the same piece of code over and over again and forget other stuff, and also to make just educated decisions on where to do refactoring and where not to. Hypothesis brings your limitations into a known situation, but it also discourages dependencies on changing code. So if you are depending on some code that is constantly changing a little bit, that influences your code, then the limitations will change all the time and hypothesis will complain. So it makes it pushes to have little dependencies and these dependencies to be stable dependencies, which is something that I personally really like. And last but not least, git log-s and git bisect, they help you a lot if you have small git commits with reasonably helpful commit messages. And all this together leads to a world where you can have confidence in your work and have confidence in your keywords and your libraries and your results, and have generally an enjoyable environment to work with. Thanks a lot for your attention. Any questions?